This presentation is about the history of probability.
So what exactly is probability? Probability is a branch of mathematics that deals with the laws governing random events. It has been a part of human life since ancient times and can be found in diverse areas, such as fortune-telling, games of chance, philosophy, law, insurance, and errors of prediction in astronomy and medicine. For instance, in approximately 1200 BC, an ancient game was played using 4 astragali made from animal bones. This is where the idea of the pips, which are the dots on the dice we use today, originated. Gambling has been a popular pastime among the wealthy since the 1650s, and it was during this time that the concept of probability began to develop. Interestingly, many of the famous mathematicians who developed the concept of probability were themselves avid gamblers. In ancient times, people who gambled believed that the outcome of the game depended solely on luck, so they never expected any outcome to be more likely than the other. However, this belief did not last long. Soon after, mathematicians started finding connections between gambling and probabilities, perhaps around the 16th century. Girolamo Cardano was one of the first people to ever write about probability. In 1564, he wrote a book named Liber de Ludo a Lei, Games of Chance, which contained the first ever use of probability, along with a few effective cheating techniques. He also expressed the efficacy of defining odds as the ratio of favorable to unfavorable outcomes. A century later, 2 of the greatest mathematicians of all time, Pierre de Fermat and Blaise Pascal, independently worked on the problem of points and presented their solutions. This brings us to the infamous Pascal-Fermat correspondence of 1654. The origin of modern probability theory is often traced back to an event between Pierre de Fermat and Blaise Pascal, 2 French mathematicians, in 1654. The problem that inspired them was related to gambling and was proposed by a philosophical gambler named Chevalier de Marais. The problem dealt with determining the proper distribution of stakes in a game of chance that gets interrupted, and it is also known as the problem of points. The problem of points states as such: there are 2 players, A and B, playing a fair game of rounds. The one who wins a total of 6 rounds initially will receive a reward. Now suppose due to any reason the game has to be stopped unexpectedly while A has won 5 rounds, and B has won 3. Then how would the reward be divided among the 2? Both Pascal and Fermat proposed different solutions to a problem, but they somewhat agreed on the numerical answer. Fermat gave his answer in terms of chances or probabilities, while Pascal proposed to solve the problem not in terms of chances, but in terms of the quantity now known as expectation. As a result, Blaise Pascal is now regarded as the father of probability theory. Games of chance, such as this one, provided model problems for the theory of chances during its early period, and indeed they remain staples of the textbooks even today. A posthumous work of 1665 by Pascal on the arithmetic triangle, now linked to his name, showed how to calculate numbers of combinations and how to group them to solve elementary gambling problems. However, Fermat and Pascal were not the first to give mathematical solutions to problems such as these. More than a century earlier, the Italian mathematician, physician, and gambler Girolamo Cardano calculated odds for games of luck by counting up equally probable cases. Girolamo Cardano is widely regarded as the first person to develop the concept of probability. However, his work on this topic was not published until centuries after his death. During that time, the ideas behind probability were already being discussed and put into practice. Cardano was a professor of mathematics and medicine in Italy, and he was also a passionate gambler. He played games of chance daily, but he believed that if he wasn't going to win money, then he could be doing something more worthwhile, such as learning. This idea led him to investigate the chances of pulling aces out of a deck of cards and also rolling sevens with 2 dice. Cardano was the first to realize that there was an equal chance of rolling a 1, 3, or 5 as there was of rolling a 2, 4, or 6. This meant that people could bet accordingly if the dice were fair. However, if the dice were not fair, then the bets would need to be adjusted to accommodate for that. As a mathematical subject, the theory of probability arose very late, despite the fact that we have prehistoric evidence of man playing with dice from cultures from all over the world. One of the earliest writers on probability was Girolamo Cardano. He perhaps produced the earliest known definition of classical probability. After the problem of points throughout the 18th century, the application of probability moved from games of chance to scientific problems. The classical definition of probability was first introduced by Bernoulli and Laplace. Later, mathematicians attempted to redefine probability using frequency-based approaches, but these attempts were not widely accepted, leading to a stagnation in probability mathematics. Frequentist interpretation of probability relies on the frequency of repeatable experiments. This approach addresses issues with the classical interpretation and considers probabilities only in the context of well-defined random experiments. In 1933, Kolmogorov, a Russian mathematician, outlined an axiomatic approach that forms the basis for the modern theory. Since then, his ideas have been refined, and probability theory is now part of a more general discipline known as measure theory. Probability has come a long way. Probability today is used in all types of areas in real life, including weather forecasting, sports betting, investing, and more. Many retail companies use probability to forecast sales, while individuals use it to make decisions like driving. I would like to end this presentation by sharing a quote from Pierre-Simon Laplace. Probability theory is nothing but common sense reduced to calculation. I appreciate your time and hope you find this presentation valuable. Thank you.